Hello everyone and welcome back to our Python Climate Health Data Science workshop. I'm Chi and today's session is about using Google Earth Engine with Python. We'll cover the basic of getting started with GE Python's API, and we will walk through some example code of importing the library, setting up the environment, loading data, and visualizing it in an interactive map. So, Google Earth Engine is a cloud-based computing platform that combines a massive catalog of satellite imageries and geospatial datasets with planetary scale analysis capabilities. However, it is worth noting that what we'll cover today is just really scratching the surface of what's possible with the Google Earth Engine platform. And for those who are interested in diving deeper, there are several excellent resources available. So today's tutorial is actually adapted from the National Center for Ecological Analysis and Synthesis. They provide a very comprehensive material and tutorial on geospatial analysis, and you can find their complete tutorial by clicking this hyperlink, and it will be redirected to you this extensive Google Earth Engine tutorial. And additionally, Google has provide an official extensive data catalog in this link where you can explore the full range of available datasets on Google Earth Engine platform. So classic remote sensing data such as Landsat and Sentinel are all available on Google Earth Engine. And if you want more advanced usage and detailed example, Google Earth Engine official tutorial on the developer page is also a good guide for you. Especially they have very detailed documentation and also official example for using Google Earth Engine with Python. To start today's session, let's first begin by setting up our environment and walking through some of the basic steps of accessing and visualizing geospatial data with Google Earth Engine. So to work with Google Earth Engine in Python, we need to import two key packages. First, we have the EE packages, which stand for Earth Engine, and this is the official Google Earth Engine's Python API. And second, we're going to use the GEE map, which is a Python package that makes it easier to work with the Earth Engine data, specifically in a Jupyter notebook environment. So once you import these two packages, now we need to trigger the authentication process. And you can run the ee.authenticate code. And this is a security measure that ensures only authorized users can access the platform. And when you run this command for the first time, Earth Engine will open a web browser window where you will need to sign in with your Google account and grant the necessary permissions. And once you have completed this step, you'll receive a verification code to paste it back to this notebook. Here, it states the print result is true. It was because I have already authenticated my Google account to this notebook, so I don't need to redo this again. But if you're running this to the first time, it will redirect you to on the authenticate page, and what you need to do is just to sign in with your Google account and then copy the authentication code and put it back, input it, and this will come through. So once we have authenticate, we need to initialize our Earth Engine session, and then we use this using the ee.initialize function. And with these steps completed, we can now create our very first visualization. So let's try to set up a basic interactive map using the GEE map. And we'll center it on West Africa. So here, the center parameter is where you can specify the longitude and latitude, and also you can specify the zoom level. And if you run this code, it's going to give you an interface where you have an interactive web map of the globe that's centered around West Africa, and you can further even zooming in and toggle around with this. So after this, now let's try to work with some actual Earth Engine data. So we're going to use the Area 5 weather data collection, which is a comprehensive global climate data set. So the way to access the Area 5 code is using the function of ee.image collection, and then you specify the file path. So this line of code is telling Google Earth Engine to access the Area 5 daily weather data collection from the European Center for Medium Range Weather Forecast. And when we write this code, you'll notice that there is an EE prefix, and this indicates that we're using an Earth Engine specific objects and method, but not regular Python objects. And this looks like a simple Python function call, but it's actually requesting data that lives on Google server, not on your local machine. And once we have access it, we can check out our data type that we are working with, and we can see that it is a Google Earth Engine image collection object. And also you can select the desired band. So on the weather data object, you have different variables. And for this tutorial, we're going to work with the total precipitation. So once we have select the precipitation variable, now we can define a specific time period that we want to analyze. In this example, we'll look at the precipitation data for the year of 1995. And the dates are specified in year, months, day format. And notice that the end date is set to the start of 1986 because the filter date method is inclusive of the start date but exclusive of the end date. And now we can combine our multiple operations to process our data. So this line of code will select the variable total precipitation and then filter it to the dates that to the time period that we just specified. And in the end, we have a mean function to calculate the mean precipitation across the entire period. So once we activate that, so once we run this code, we have the mean precipitation data sets, and we can examine the result. So here you can see that we have a one band images, and we can see that our output is now a single Earth Engine image object rather than an image classification that we saw before. And this image contains the average precipitation values for our specified time period. And you can also see the attributes, including the data types. It is a float, and also the coordinate reference system. It is WGS84, and also the transformation information. So once we have our average precipitation band, now we can try to plot it. So first, we need to create a color plate to represent our data value. And here we can just manually define a customized color plate. So here we set the minimum value of 0 and maximum value of 0.01 for scaling our precipitation data. And then we define a color gradient, which is from white to red, that represents the precipitation. And now we can add our precipitation data as a layer on our map. Here we are adding the precipitation data with our customized color plate, and we're labeling as total precipitation. Also, we set the transparency, and now you can see that we again have the interactive map, and we can see that the average annual precipitation is being loaded. You can see that those are more reddish are the areas with higher annual precipitation value in West Africa. And this visualization gives us a clear view of the precipitation patterns. And now let's look at another example. So we can also use Google Earth Engine to focus on a specific region and try to export our data. And in this example, we're going to analyze the precipitation around Lyon at France. So first, we need to define our location of interest. And in this case, we're using the longitude and latitude coordinates for Lyon. Next, we're going to create a region of interest by adding a buffer around our point. And then to focus on the country of France, we need to get its administrative boundaries. And since Google Earth Engine has a lot of available datasets, it also has the vector data that has the word administrative boundary. Here we're using the FAO datasets to select the country of France to select its boundary. And then we use this code to clip the image to the extent of France. And finally, we can now create a visualization URL for our clipped dataset. Here again, we're specifying the visualization parameters for the minimum value and also the maximum value. And also here, the region, we set it to our ROI, which is the buffer zone, and so that our output will be clipped to this region. And And if we run this code and display it, it'll probably take a while. And we can see that here is our precipitation data that clipped to the boundary of France and also our ROI. And finally, if we want to download the data for further analysis, we can generate a download link. And this function will give us an URL where we can download our process data in a GeoTIFF format. And also here is the output parameters that you can specify the coordinate system, the resolution, and also the region. And if you click this link, you can download it. So to wrap up this tutorial, let me show you another powerful capability of Google Earth Engine. That is, we can directly work with satellite imagery. So as we said before, Google Earth Engine hosts many datasets, including the Landsat satellite collection, which we will use as an example. So here we're trying to visualize Landsat 9 data for January 2022. First, we're going to use, again, the ee.image collection function to access the Landsat 9 collection. And then we specify the time period that we are interested. Here, we're looking at January 2022. And for Landsat, we need to apply scaling factors to convert the raw values into meaningful measurements. And here is the official function to do that. And then we can, using the map function, to apply the scale factor to our raw image band value. And then we set the visualization parameters and using the GE map to map our Landsat satellites, and then set the center and add the layer. And now we can see that now we have on the coastline of Ghana in Landsat 9 images. And you could also try to zoom out a little bit and see how it looks on January 2020 for the Landsat 9 image. And that is all for our quick tutorial today about Google Earth Engine. And again, here is just a very light touch of Google Earth Engine in Python. And there are tons of other good resources and tutorials that you can follow. And I would highly encourage you to check out the links that we provided and dive deeper into Google Earth Engine.